So we are moving on to talk about autonomic nervous system. Now, I am working really hard towards one of my goals, which is you're going to hate me for saying that same phrase. You're going to need it in AP2. Basically, AP2, the entire class, is like 40% are autonomic controls of different organs, from your digestive system to cardiovascular to respiratory, you name it. Okay, it's all autonomic. You have no conscious power over those functions. So that's kind of, important. So let's start with two branches of autonomic nervous system. There is, I'm going to try and kind of divide them more or less equally. Yeah, so I have like a line one next to another. So we have sympathetic, and I'm going to use the letter S, branch, and we have parasympathetic. Branch. They are different. They are different functionally. They are different anatomically. So what I want to do, we're going to mention in general what is the functional difference, and then we're going to jump onto the anatomy. And we're going to discuss the anatomy of both systems in details. And then we're going to switch back to sort of cellular organization, receptors, neurotransmitters, and we're going to conclude it with the what they do, like actually do. Okay, good? Okay, so let's start with the cool names. So sympathetic nervous system, known as fight or flight. Okay? Basically, this is the system that increases its activity in some kind of an excitement. It ranges from going to the gym to your response to the attack of a rabid raccoon. Parasympathetic branch is engaged in rest and digest activities. So basically your energy-saving housekeeping. Right, so sort of benign example, exercising versus sitting on the couch reading a book. Does that make sense? In some other situations, this is your immediate stress response. Okay? Questions? So far we good? Okay. I'm actually going to start with the anatomy of parasympathetic system, and I'm going to start with a kind of general organization. So, origin. Where does it start? Brainstem, okay, sacral nerves. Actually, let me add a little bit. The brainstem, and I'm going to add cranial nerves and sacral nerves. So this is why often the origin is referred to as craniosacral. Okay, does that make sense so far? I mean, it's kind of a made-up term, but it describes. It's okay. Now, which cranial nerves? And we're gonna talk about. I'm gonna do immediately like nerve. What does it do? Nerve. What does it do in general? Right? That's going to be enough. Believe me. So first one will be cranial nerve number 3. And that's going to be your oculomotor nerve. Okay, so pupil constriction. Interestingly enough, when you are sitting on the couch and reading the book, the pupil constricts. Okay. Then you have cranial nerve number 7, which is facial nerve. It has a whole bunch of functions here, mostly glands in your head. So lacrimal gland, okay, crying, maybe reading really sappy book. Nasal gland, so now you have sniffles, and I'm going to do salivary glands. So here for salivary glands, just really long words, submandibular and sublingual. So glands that are located under the tongue and under the jaw. Here, 2 glands. Okay? Good? Moving on from number 7 to cranial nerve number 9. It's your glossopharyngeal parotid salivary gland. So we're approaching the culmination, functional culmination here, which is cranial nerve number 10, and it's vagus nerve. The function is super simple. Thoracic and abdominal organs. So if you ask yourself, which nerve conveys the controlling signals to your stomach or your lungs or your spleen, kidneys, it's all going to be vagus nerve. Okay. RF came up with an extremely nerdy joke, which is what happens in vagus stays in vagus. And now you have sacral nerves here. That's the last one. Pelvic organs. Okay, we're talking about urinary bladder, reproductive organs, distal large intestine. Are we good so far? Any questions on this layout? Now, last little bit that I want to kind of finish the parasympathetic branch with is the actual organization of the motor part. So, well, as a matter of fact, before I get there, let me lay out the autonomic reflex right here between the two. So, autonomic reflex. Basically, same story as the somatic, with some minor modifications. Do we have a stimulus? Yes, we do. Reflex implies that there's a stimulus. Do we have a sensor? Absolutely. Do we have afferent neurons? Yes. They convey the signal to the central nervous system, either brainstem or spinal cord. Now what happens next? Here's the important part, really important part. So you have in somatic reflex, which is not here anymore, but in somatic reflex, there was only one efferent motor neuron. In autonomic, there are two. You have preganglionic efferent okay? There's preganglionic efferent neuron, synapses with postganglionic efferent neuron in a ganglia. Okay, so this is CNS. This is ganglia. And postganglionic efferent neuron directly controls the effector. What is the effector of the autonomic nervous system? Since it's autonomic, anything besides the skeletal muscles. So it can be glands. Here are your examples. Can be cardiac or smooth muscles. Okay, good? That make sense? Great. So now I can go back and sort of expand on pre- and postganglionic story. So this is how your parasympathetic system is organized. Disclaimer, I'm going to be using brainstem as the origin, but it's not different for sacral nerves in any way, okay? That makes sense to you? So, this here is brainstem. So here you have a really long preganglionic neuron which synapses with a really short postganglionic neuron in the structure just called a ganglion. So where is this structure located? In the wall of an organ. Okay, does that make sense? So basically, think of it this way. The preganglionic neuron extends all the way from the brain stem, goes all the way to your stomach, and then synapses with a postganglionic neuron in the wall of the stomach or extremely close to it. So close that we don't even think of it as a separate case. So basically the ganglia are in the organ walls. Are we clear? This is your full layout of parasympathetic system anatomy and organization of pre- and postganglionic fibers. Let's move on to sympathetic. Origins are going to be much simpler. Spinal cord, T1 to L1, maybe L2. So basically, your spinal nerves, all thoracic spinal nerves, and a couple of lumbar, carry sympathetic fibers. Does that make sense? We're good? Now, I'm going to talk about this part first, and then I will show you some anatomical differences which imply significant physiological differences between the two systems. Okay, we're good? So, you've got spinal cord. Okay? You've got fairly short preganglionic, which synapses the really long postganglionic, and this structure right here is called sympathetic trunk. So, look at this model that I have in my hands. You see the vertebral column, right? You see the spinal nerves extending from it. Imagine, we don't have it on the model unfortunately, but imagine that there is a chain of ganglia that goes along the vertebral column. Now you're following me. This is the sympathetic trunk. It has many names. I use sympathetic trunk, but this paravertebral sympathetic chain of ganglia, paravertebral sympathetic trunk, all kinds of names. Sympathetic trunk is the one that I use the most. Okay? Good? You have one on the right, you have one on the left. Okay? Are we clear on that part? So this is a general rule for sympathetic systems. So you can clearly see the anatomical difference between the two, right? You can see that in parasympathetic, preganglionic neuron is long, postganglionic is short. Ganglia in the walls of organs. Here, preganglionic is short, postganglionic is long, ganglia are in the sympathetic trunk. We good so far? Now let's talk about one, in my opinion, extremely boring, but extremely important feature, the sympathetic branch of autonomic nervous system. And it's completely anatomical, okay? So imagine that this is the trunk, this sympathetic trunk, okay? And along with it, right here, is the spinal cord. So you have preganglionic neuron right here, which reaches into sympathetic trunk and synapses with its postganglionic counterpart at the same level. Okay? That's kind of, like, I don't know, you walk through the B building hallway and you keep going into the C building hallway without changing the floor. Okay? Another option, a neuron can go a little up, or it can go a little down. Okay, up or down, basically the same story. Okay, we're good? It's another option. So you walk on the second floor, in the B hallway you can get upstairs and go into the C, the third floor, you can go downstairs and go into the C on the first. Okay? So these are common. So basically what I'm trying to tell you is that preganglionic neuron can synapse with a postganglionic neuron at the same level, can go slightly higher in the sympathetic trunk, slightly lower, or option number 4, it can actually It's not often, but it happens. Sometimes preganglionic fiber of sympathetic system extends beyond the trunk. Okay, we good? Sometimes it happens. And it synapses with a postganglionic neuron in what is called collateral or peripheral ganglion. Okay? So for instance, there are some sympathetic preganglionic fibers that will form individual ganglia in the abdominal cavity. Not in the walls of organs, not in the sympathetic trunk, just another location. Are we good on this anatomical part? Now, I know it's boring. Like the question that should pop up in your mind, why does it matter? Functionally, it does. If you look at the organization of parasympathetic system, it is very, how to say, targeted. Very pupillary constriction. Some glands on the face. Like the signal goes through the facial nerve, all that's going to happen, you're going to cry and have sniffles. Does that make sense? Vagus is kind of distributed, but there are a lot of branches. Okay? Now, this sympathetic organization shows you one important difference. It looks somewhat like plexuses in somatic spinal nerves. Okay? So you can have a very local activation, very local sort of activation in the spinal cord. Signals will reach all the way through. Sympathetic system is much more branched. Okay? And due to that extensive branching, as a general rule, and that's an important rule, as a general rule, parasympathetic responses are usually very local. Sympathetic responses are always systemic. Does that make sense, what I just said? So, in other words, which I'm dangerously walking far and far away from like strict physiology, but for kind of gut feeling understanding, sympathetic responses are very, very strong. They engage virtually all systems of the body. Parasympathetic may not do that. They're much more local, much less intense, okay, which kind of makes sense. Because when you're running away from a rabid raccoon, you need everything to be recruited. Okay, we good? Make sense? Okay. Yeah, I think that's it for the anatomy.